Imagine a cosmic visitor streaking through the vast emptiness of space at a blistering 245,000 kilometers per hour, hurtling toward our sun on a path that defies everything we thought we knew about the universe. On July 1st, 2025, astronomers detected such an object named 3I/ATLAS, and it's not just another space rock. This interstellar interloper, discovered by the NASA-funded Asteroid Terrestrial Impact Last Alert System, ATLAS, in Chile, has sparked a firestorm of debate among scientists and stargazers alike. Is it a natural comet forged in the crucible of a distant star system? Or could it be something far more extraordinary, a nuclear-powered spacecraft sent by an alien civilization to test humanity's response? Buckle up, because this cosmic mystery is about to take us on a wild ride through the stars, blending cutting-edge science with tantalizing possibilities that could reshape our understanding of the cosmos. Let's dive into the story of 3I/ATLAS, explore its bizarre behavior, and ask the question that's gripping the world: what if this is no ordinary comet? It was a crisp night in Rio Hurtado, Chile, when the ATLAS telescope, designed to spot fast-moving objects that could threaten Earth, caught something extraordinary in its sights. On July 1st, 2025, astronomers observed a faint speck of light moving at an astonishing speed, over 245,000 kilometers per hour, faster than any object ever recorded in our solar system. This wasn't just another asteroid or comet orbiting our sun. Its trajectory was hyperbolic, meaning it wasn't bound to our star's gravity. Instead, it was a visitor from interstellar space, only the third of its kind ever detected, following Oumuamua in 2017 and 2I Borisov in 2019, named 3I/ATLAS, where 3I stands for the third interstellar object and ATLAS credits the telescope that spotted it. This cosmic traveler immediately stood out. Its orbit was unlike anything astronomers had seen before, skimming just 5 degrees from the ecliptic plane, the imaginary disk where Earth and most planets orbit the sun. The odds of a random interstellar object aligning so closely with this plane, a mere 0.2%, or 1 in 500, but that was just the beginning. As telescopes worldwide turned their gaze to 3I/ATLAS, they uncovered a series of anomalies that would challenge our understanding of the universe and ignite a debate that's still raging today. Picture this: a massive object, potentially up to 20 kilometers wide, barreling through our solar system, passing within 29 million kilometers of Mars on October 3rd, 2025, and reaching its closest point to the sun, its perihelion, at 1.35 astronomical units, about 202 million kilometers on October 30th. It will swing within 33 million kilometers of Jupiter later, a trajectory that brings it improbably close to 3 major planets. The combined probability of these close encounters happening by chance? A staggering 1 in 20,000. As astronomers scrambled to analyze this visitor, one question loomed large. Could 3I/ATLAS be more than just a comet? Could it be a sign of something or someone watching us from the stars? As the Hubble Space Telescope trained its powerful lens on 3I/ATLAS on July 21st, 2025, it captured an image that sent shockwaves through the astronomical community. The object appeared as a fuzzy snowball, surrounded by a teardrop-shaped cocoon of dust, with a faint coma and hints of a tail, classic signs of a comet. But something was off. The glow emanating from 3I/ATLAS wasn't behaving like that of a typical comet. Most comets reflect sunlight, their brightness determined by the amount of light they scatter back to Earth. Based on this model, 3I/ATLAS would need to be a colossal 20 kilometers in diameter to produce the observed brightness, making it 40 times larger than Oumuamua, about 100 meters, and 20 times larger than 2I/Borisov, less than 1 kilometer. But here's where the story takes a dramatic turn. Harvard astrophysicist Avi Loeb, no stranger to bold ideas, co-authored a paper with colleagues Adam Hibbard and Adam Kroll from the Initiative for Interstellar Studies, proposing a radical hypothesis. What if 3I/ATLAS isn't just reflecting sunlight, but generating its own light? If true, this self-illumination would mean the object could be much smaller, potentially just hundreds of meters across, completely upending our size estimates and opening the door to mind-bending possibilities. Loeb's team pointed to the object's brightness profile, which is unusually steep compared to typical comets. Unlike the gradual brightening and dimming seen in objects reflecting sunlight, 3 3I/ATLAS's glow appeared more like a point source, almost as if it were emitting light independently. This anomaly led Loeb to speculate that the object could be powered by something extraordinary, perhaps radioactive decay, thermal emissions from an internal heat source, or most provocatively, artificial illumination from advanced technology. The idea of a self-luminous object isn't just a scientific curiosity, it's a game changer. If 3I/ATLAS is generating its own light, it could be a technological artifact, a probe sent from another star system to explore our cosmic backyard. The trajectory of 3I/ATLAS is where the mystery deepens. Unlike most comets, which follow elliptical orbits around the sun, 3I/ATLAS is on a hyperbolic path, meaning it will pass through our solar system once and never return. Its orbit is remarkably flat, tilted just 5 degrees from the ecliptic plane, a precision that's statistically rare for a random interstellar object. But it's the object's close encounters with Mars, Venus, and Jupiter that have raised eyebrows. The probability of an interstellar object passing so close to 3 planets is a mere 0.005%, or 1 in 20,000. Loeb's paper suggests this trajectory could be deliberate, designed to maximize observations of our solar system's planets. Adding to the intrigue, 3I/ATLAS will reach its perihelion when Earth is on the opposite side of the sun, obscured by solar glare. This timing is perfect for a spacecraft executing a reverse solar Oberth maneuver, a high-thrust strategy to slow down and potentially remain in our solar system, all while hidden from Earth's telescopes. If this were a natural comet, the alignment and timing would be an extraordinary coincidence. If it's artificial, it could suggest a level of planning that sends chills down the spine. But let's pause for a moment and consider the counter-argument. Most astronomers, including David Jewett from UCLA, argue that 3I/ATLAS is a natural comet. Its coma, a cloud of gas and dust and tentative tail-like elongation, observed on July 2nd, 2025 by telescopes like the Lowell Discovery Telescope and the Canada-France-Hawaii Telescope, align with typical cometary behavior. The dust production rate, estimated at 6 to 60 kilograms per second, and ejection velocities of 20 to 2,000 meters per second fall within expected ranges for comets. Moreover, the object's water ice signatures, detected by the Gemini South and NASA Infrared Telescope facility, suggest it could be pristine material from another star system, offering a rare glimpse into the chemistry of distant worlds. Avi Loeb is no stranger to controversy. In 2017, he proposed that Oumuamua, the first known interstellar object, might be an alien probe due to its unusual cigar shape and non-gravitational acceleration. Now, with 3I/ATLAS, he's doubled down, suggesting it could be a technological artifact, possibly even a hostile probe testing humanity's defenses. In a blog post, Loeb ties this idea to the dark forest hypothesis, a concept from Tixon Liu's science fiction novel, which posits that intelligent civilizations remain silent to avoid detection by predatory species. If 3I/ATLAS is artificial, Loeb argues, its trajectory and timing could be evidence of a reconnaissance mission designed to study our solar system while minimizing detection. Loeb rates 3I/ATLAS a 6 out of 10 on his Loeb scale, where 0 is a definitely natural object and 10 is a confirmed technological artifact. He admits the alien hypothesis is a long shot, emphasizing that it's a pedagogical exercise to encourage data collection. But he also warns that if it's technological, the implications could be dire for humanity, potentially requiring defensive measures. Critics like Oxford astronomer Chris Lintott dismiss these claims as nonsense on stilts, arguing they distract from the exciting scientific work being done to study 3I/ATLAS as a natural comet. Yet the possibility of self-illumination keeps the debate alive. If 3I/ATLAS is generating its own light, it would need to produce approximately 10 gigawatts of power, equivalent to several large power plants. Sustaining that over millions of years of interstellar travel would require an extraordinary energy source, far beyond our current technology. Radioactive decay could produce a glow, but finding enough radioactive material in interstellar space is unlikely. Thermal emissions from an internal heat source are another possibility, but maintaining such temperatures without solar heating is a stretch. The most tantalizing option remains artificial illumination, which would imply a level of technology we can scarcely imagine. As 3IATLAS hurtles toward its perihelion, astronomers are racing to gather data before it fades from view. The James Webb Space Telescope, JWST, with its unparalleled infrared capabilities, is set to scrutinize the object's temperature profile and energy output, potentially revealing whether its glow is natural or artificial. Meanwhile, NASA's Mars Reconnaissance Orbiter could capture high-resolution images during the comet's close approach to Mars on October 3rd, 2025, offering our best chance to study its surface up close. These observations could confirm whether 3I/ATLAS is a comet with a dusty, icy nucleus or something far stranger. The Vera C. Rubin Observatory, which began operations in 2025, is another game changer, capable of detecting dozens of interstellar objects annually. It's already provided detailed photos showing 3I/ATLAS's nucleus is about 7 kilometers wide, making it the largest interstellar object ever seen. These images, taken before the official discovery, highlight the observatory's potential to revolutionize our understanding of interstellar visitors. Experts predict it could spot up to 50 new interstellar objects within the next decade, giving us a statistical sample to determine what's normal and what's truly anomalous. But time is running out. As 3I/ATLAS approaches the sun, it will become harder to observe from Earth due to solar glare. By early December 2025, it will reappear on the other side of the sun, offering a final window for ground-based telescopes to capture its secrets. If it's a comet, we expect to see increased gas emissions as solar heating intensifies, with volatile ices like CO2 and water sublimating into a spectacular coma and tail. If it's something else, we might detect radio emissions, electrostatic discharges, or even intentional course corrections, hallmarks of a technological artifact. Let's zoom in on another fascinating aspect of 3I/ATLAS, its composition. Spectroscopic data from the Gemini South Observatory and the NASA Infrared Telescope Facility, updated as of August 27, 2025, reveal a cocktail of water ice, carbonaceous minerals, and silicates. This isn't just any ice. It's chemically pristine, lacking the heavy isotopic signatures typical of solar system comets. This suggests 3I/ATLAS could have formed billions of years ago in a distant star system, carrying with it a chemical snapshot of a world we've never seen. Imagine holding a piece of another galaxy's history, a relic that's traveled light years to reach us. This composition alone makes 3I/ATLAS a treasure trove for scientists studying the formation of planetary systems, offering clues about the building blocks of worlds far beyond our own. But here's where the alien hypothesis creeps back in. If 3I/ATLAS is a technological probe, the dust and ice we're observing might not be part of its core structure, but rather cosmic debris accumulated over eons of interstellar travel. Picture a spacecraft, sleek and advanced, collecting a crust of ice and dust as it drifts through the galaxy's molecular clouds, much like a ship gathering barnacles on a long sea voyage. This cosmic patina could mask its true nature, making it appear as a comet to our telescopes while hiding a technological core. The high CO2 to water ratio reported by the European Southern Observatory on August 15, 2025, is particularly intriguing, as it's unusual for solar system comets, but could be consistent with material swept up from a different stellar environment. This duality, natural relic or disguised probe, keeps astronomers on edge, as every new observation could tip the scales. The dust trail also tells a story of motion. The ejection velocities, ranging from 20 to 2,000 meters per second, suggest dynamic activity, but the absence of volatile gases like cyanogen or diatomic carbon at its current distance, about 4 astronomical units from the sun, isn't surprising. Most comets don't turn on until they're closer to the sun, where solar heating triggers outgassing. If 3I/ATLAS follows this pattern, we'll see a dramatic increase in activity by late October 2025, potentially revealing a vibrant coma and tail. But if it remains quiet or shows unexpected emissions like radio signals or non-thermal glow, it could bolster the case for an artificial origin. This cosmic dust trail, then, is both a scientific goldmine and a tantalizing clue in the puzzle of 3I/ATLAS's true identity. Let's step back and grapple with the sheer improbability of 3I/ATLAS's existence. Avi Loeb's calculations, published in his August 2025 paper, highlight a statistical anomaly that's hard to ignore. The reservoir of rocky material in interstellar space is sparse, with large objects like a 20-kilometer wide asteroid being exceedingly rare. For such a massive object to visit our solar system, Loeb estimates it would happen once every 10,000 years or more. Yet here we are with 3I/ATLAS blazing through our cosmic neighborhood, potentially the largest interstellar object ever observed. If it's natural, we've hit the cosmic lottery, a 1 in a million chance to study a massive relic from another star. But if it's smaller and self-luminous as Loeb suggests, the odds shift dramatically, making its presence far more plausible but no less extraordinary. This statistical quirk ties into the broader question of interstellar objects. Before Oumuamua, we had no confirmed interstellar visitors. Now, in less than a decade, we've seen 3, and the Vera C. Rubin Observatory predicts dozens more in the coming years. This raises a profound question. Are we just getting better at spotting these objects, or is there something about our solar system that's attracting them? Some researchers, like Daryl Seligman from Cornell University, suggest that interstellar objects might be more common than we thought, with smaller fragments littering the galaxy. But 3I/ATLAS's size and trajectory challenge this idea. Its precise alignment with the ecliptic plane and close planetary encounters suggest a path that's almost too perfect, as if it were engineered to maximize its tour of our solar system. This statistical improbability fuels both excitement and skepticism, pushing scientists to question their assumptions about the cosmos. The implications of this anomaly extend beyond science into philosophy. If 3I/ATLAS is natural, it's a reminder of how rare and precious these interstellar visitors are, each one a messenger from a distant star. If it's artificial, it could mean we're not alone in the galaxy, and that someone or something has taken an interest in us. The odds of either scenario are mind-boggling, but they force us to confront our place in the universe. Are we a cosmic accident, a fleeting spark in an indifferent void, or are we part of a larger story, one where other intelligences are reaching out across the stars? As 3I/ATLAS speeds toward its destiny, it's challenging us to rethink what's possible and to embrace the uncertainty of the unknown. The story of 3I/ATLAS isn't just about a mysterious object. It's about humanity's relentless pursuit of truth. From the Atlas team in Chile to the astronomers analyzing Hubble data in Baltimore, this discovery has united scientists across the globe in a shared mission. Amateur astronomers, too, are joining the effort, using backyard telescopes to track 3I/ATLAS's faint glow. On platforms like X, posts from users like at StarChaser42 and at Astro Enthusiast as of August 27, 2025 show a groundswell of public excitement, with thousands sharing images and theories. This global collaboration mirrors the spirit of exploration that drove humanity to the moon and Mars, reminding us that curiosity is a universal language. But this quest isn't without challenges. The debate over 3I/ATLAS's nature has sparked heated discussions, with some accusing Loeb of sensationalism, while others praise his willingness to ask bold questions. Social media is abuzz with speculation, from plausible theories about exotic cometary physics to wild claims of alien invasions. Yet, amidst the noise, there's a deeper truth. 3I/ATLAS is bringing people together, inspiring students, scientists, and dreamers to look up and wonder. Educational outreach programs, like those hosted by the SETI Institute in August 2025, are using 3I/ATLAS to teach kids about spectroscopy and orbital mechanics, igniting the next generation of explorers. This human element adds emotional weight to the story. Every observation, every data point is a testament to our desire to understand the universe. Whether 3I/ATLAS is a comet or a probe, it's a catalyst for connection, pushing us to share ideas, debate possibilities, and dream of what lies beyond. As we await the next batch of data from JWST and the Mars Reconnaissance Orbiter, we're not just watching a cosmic object, we're participating in a global adventure, one that could redefine our understanding of life, intelligence, and our place in the stars. Now, let's explore a thrilling possibility. What if 3I/ATLAS is trying to communicate? If this object is indeed a technological artifact, it might emit signals, radio waves, laser pulses, or even more exotic forms of communication that our instruments could detect. As of August 27, 2025, the Breakthrough Listen project, funded to search for extraterrestrial intelligence, has turned its Green Bank Telescope and Parkes Observatory toward 3I/ATLAS, scanning for narrowband radio emissions that could indicate artificial origin. So far, no definitive signals have been detected, but the search is ongoing, with plans to intensify observations as the object nears Mars in October. The prospect of picking up a signal from another civilization is both exhilarating and daunting, as it would confirm we're not alone while raising questions about the sender's intentions. Detecting such a signal is no small feat. Interstellar space is a noisy place, filled with cosmic background radiation and interference from our own technology. To identify an artificial signal, scientists look for patterns that defy natural explanations, like a steady, repeating pulse or a frequency modulated in a way that suggests intelligence. The Allen Telescope Array, operated by the SETI Institute, is also monitoring 3I/ATLAS, focusing on frequencies between 1 and 10 gigahertz, where artificial signals are most likely to be found. If 3I/ATLAS is a probe, it might be dormant, conserving energy for a specific task, or it could be actively broadcasting, waiting for a response. The challenge is that our technology, advanced as it is, might not be equipped to recognize a signal from a civilization far beyond our own. This possibility underscores the importance of open-mindedness in science, pushing us to develop new tools and methods to explore the unknown. The arrival of 3I/ATLAS is more than a singular event. It's a preview of the future of interstellar exploration. The Vera C. Rubin Observatory, with its ability to detect dozens of interstellar objects annually, is ushering in a new era of discovery. By 2035, scientists estimate we could have cataloged over 50 such visitors, each offering a chance to study the chemistry, dynamics, and origins of objects from beyond our solar system. 3I/ATLAS, with its unique brightness profile and precise trajectory, is a wake-up call, reminding us that the galaxy is teeming with mysteries waiting to be explored. Whether it's a comet or a probe, it's teaching us to refine our observational techniques, from spectroscopy to high-resolution imaging, and to question our assumptions about what constitutes a normal interstellar object. This moment also sparks imagination about our own interstellar ambitions. If 3I/ATLAS is artificial, it could inspire humanity to accelerate projects like Breakthrough Starshot, which aims to send tiny probes to nearby stars. Even if it's natural, its pristine composition offers a blueprint for understanding how planets form, informing future missions to explore exoplanetary systems. The data we collect from 3I/ATLAS, whether it's chemical signatures or potential signals, will shape the design of next-generation telescopes and spacecraft. As we stand on the cusp of this cosmic frontier, 3I/ATLAS is a reminder that exploration is not just about finding answers, but about asking better questions. It's a call to invest in science, to dream big, and to prepare for a future where humanity might one day send its own probes to the stars, or greet those sent to us. So why should you care about a distant space object that poses no threat to Earth? Because 3I/ATLAS isn't just a cosmic curiosity, it's a window into the unknown. If it's a natural comet, its pristine water ice and high CO2 to water ratio could reveal how planetary systems form in other parts of the galaxy. Its composition, potentially billions of years old, might hold clues to the origins of life itself. But if it's artificial, the implications are staggering. It would be the first concrete evidence of extraterrestrial intelligence, forcing us to rethink our place in the universe. Are we alone, or are we being watched? Is the cosmos a friendly place, or, as the Dark Forest hypothesis suggests, a dangerous one where silence is survival? This mystery also highlights the power of human curiosity. Astronomers worldwide, from professionals at NASA to amateur stargazers, are collaborating to study 3I/ATLAS, pooling data from telescopes in Chile, Hawaii, and Arizona. Their work reminds us that science thrives on asking bold questions, even when the answers are uncertain. Whether 3I/ATLAS is a comet or a probe, it's pushing the boundaries of what we believe is possible, challenging us to look up and wonder. As 3I/ATLAS speeds through our solar system, we're at a pivotal moment in human history. Will we uncover a natural wonder or evidence of alien technology? The next few months, October's Mars flyby, the hidden perihelion, and December's reappearance will be critical. This is your chance to be part of the story. Share your thoughts in the comments. Do you think 3I/ATLAS is a comet, a probe, or something else entirely? Like this video to show your support for exploring the cosmos, and subscribe to stay updated on the latest discoveries. The universe is vast, and 3I/ATLAS is a reminder that its secrets are within our reach if we dare to look. Let's keep our eyes on the stars. Whether 3I/ATLAS is a natural marvel or a beacon from another civilization, it's a call to embrace the unknown. As the Vera C. Rubin Observatory prepares to uncover more interstellar visitors, we're on the cusp of a new era in astronomy. So grab your telescope, join the conversation, and let's unravel this cosmic enigma together. The truth is out there, and it's closer than ever.